times. So one of the best things I can do with that steam, you're going to notice the sides of this get a little bit cloudy. Some steam is going to form up. But a lot of times the steam will actually form up even better when it condenses around something like dust or dirt or some smoke. So I'm going to light a match.
I didn't get to go to my house.
There we go. And I'll let this match kind of do its thing. And then I'm going to...
You went to all of that?
There we go. All right, cool. Now I got a lot of steam. Actually, this is the best one I've done so far. Look how cloudy it is in there now. So steam really likes to form around, or clouds, they really like to form around different particles that are in the air. So a lot of your clouds, like the clouds that you'll see up in the sky, looks kind of just like that, but it's because it formed around something, whether that was dust or maybe even some smoke. Also, on the top of this, look how much water is collected and condensed on the top. That's what your clouds look like. Eventually, all of that turns into big raindrops. So those are essentially raindrops that have kind of formed up on the top of this lid. But this happens like, you have thousands and millions of little glass beakers like this up in the sky. Okay? All right, so we have the steam inside. Ready for the cloud to come out?
Let it go out.
So this is what that cloud will essentially look like. Then a lot more steam in there at first, or it didn't have as much steam at first, did it? But over time, we created more and more water vapor in here. So that's all the cloud is. All it is just a lot of condensed water droplets. Water droplets are really, really small, especially water vapor. Okay? So inside of these clouds, though, there's a lot of temperature fluctuations. Okay, the air temperature is either warming or it's cooling, and sometimes these reactions are these temperature changes are happening due to chemical reactions that are happening in the air. A lot of it's just water is changing from water vapor to a raindrop, or maybe a raindrop to a snow crystal or a big piece of ice. So we're going to kind of do something like this. So who here has mixed together baking soda and vinegar? Have you ever done that before where it fizzes up? Yeah. Okay, so this is a pretty easy experiment. So what I want to do is try to figure out whether or not you think the temperature of this vinegar is going to get warmer or colder after the chemical reaction. All right, so right now the temperature of that liquid, it's about 68 degrees. All right. So when I add the baking soda in, what do you think is going to happen to the temperature of that liquid? Is it going to get warmer or is it going to get colder? Warmer. Who here thinks it's going to get warmer? Warmer? Okay. Who here thinks it's going to get colder? Okay. All right, here we go. And I'll mix that together. See all the foam that's forming up? All that is just carbon dioxide and oxygen. Yeah. So the chemical reaction that's done when you do this, the water that's left in here.
Oh gosh. It's like, what in the world is happening?
What just happened? All right, so now we just made some salt water. That's the chemical reaction that's made once you do this.
Salt water. Really?
Yeah. So sodium bicarbonate is it's what baking soda is, and the end product is salt water in here, and carbon dioxide and oxygen released in its gas form. Yeah. Okay, so the temperature was originally 68 degrees, right? What is it reading now? Yeah, 63. So what happened?
Got colder.
The liquid got colder.
Oh, I was way wrong.
So that's what's, anytime, like, so when raindrops are formed in the clouds, so the clouds, we made a cloud a moment ago, but at the top, there were little raindrops that formed up, right? So when those raindrops are forming, the air around those raindrops actually warmed up. It can warm up as much as 3, 4, or 5 degrees. And some of those raindrops are actually cooling around it. So the condensing process of water will actually cool the liquid, whereas the air around it got warmer. In this experiment, the water got colder because the gas that was released was really, really warm. It's called an exothermic reaction. That's a big word, but what happened was the gas that was released was really, really warm. So we took heat away from this, which meant that temperature of that liquid had to do what? Yeah, it had to go down. If you take something away from it, if you take temperature away from something, the temperature has to drop to compensate. Okay, so inside a cloud,